Hello again. Now we will estimate the IXY, the product of inertia, to make sure that it is equal to 0. So our calculation for bending of stress to follow the previous assumption of pure moment. From the assumption of pure moment, we have the neutral axis must pass by the CG. This is number one. Number two, for the two perpendicular axes should be principal axis, i.e. IXY should equal to 0. When we calculate the IXY and find it is not equal to 0, then we have to look to any orthogonal axis that will give us IXY equal to 0. Still, we have the polar moment of inertia is constant, so it means that we have a plenty of axes that will achieve I polar of inertia equal to IX plus IY, or equal to IX1 plus IX2, or IX dash plus IY dash. But the axis which we are looking for is they will achieve that the moment of inertia around, for example, X dash will be maximum, and the moment of inertia around Y dash will be minimum, and at the same time the IX dash Y dash should equal to 0. These are the principal axes that will achieve our target that IXY should equal to 0. In order to get an expression, we will make a general expression by using X and Y axes, and we'll assume that we have inclined the two axes X dash and Y dash having angle equal to theta. For small strip dA, the coordinates is X and Y, and at the same time relating to the new two axes, they are X dash and Y dash. In order to have a relation between X dash and Y dash and X and Y, we can find out that X dash equal to X cosine theta plus Y sine theta. This is this portion of the X dash. While for the Y dash, this is the Y dash. Y dash equal to Y cosine theta. This is a Y cosine theta. This is all this length minus X sine theta. Then we proceed to calculate the moment of inertia about X dash and Y dash. At the same time, we want to get an expression for Ix dash Y dash. As we know that Ix dash will be the integration of dA multiplied by Y dash square. This is the dA. And we want to take moment of inertia about X dash. So we have the integration of dA multiplied by Y dash square, while for the moment of inertia around Y dash, it will be equal to dA multiplied by X dash square, while for X dash Y dash product of inertia is equal to the integration of dA multiplied by X dash Y dash. We'll utilize the relation which we have obtained X dash and Y dash before, and we'll proceed, and then Ix dash equal to the integration of dA multiplied by Y cosine theta plus sine minus X sine theta all squared, while Iy dash equal to the integration of dA X dash square, as we can see, is equal to the integration of dA multiplied by the square of X cosine theta plus Y sine theta, while Ix dash Y dash will be the integration of dA multiplied by X cosine theta plus Y sine theta multiplied by Y cosine theta minus X sine theta. We will proceed. As you can see, this is a long calculation to some extent, but we are going to try to get expression for tan 2 theta, and at the same time we will know that we will get maximum Ix when dIx dash over d theta equal to 0, which will give us maximum and minimum value. So we are going to integrate. This is the expression we have after clearing all the thetas. We have Ix dash equal to 1/2 Ix plus Iy plus cosine 2 theta multiplied by Ix minus Iy minus Ixy times 2 theta. If we are going to integrate it, the first term will become 0, plus 1/2 the cosine 2 theta will becoming minus sine 2 theta divided by multiplied by 2 and multiplied by x minus iy, and for that term we have the differentiation of sine 2 theta is 2 cosine 2 theta multiplied by 2 again by ixy will equate to 0. When we equate to 0, we have iy minus ix. Because of the negative sign, iy minus ix multiplied by tan 2 theta, which is here, equal to 2 cosine 2 theta ixy. So we get our expression which is tan 2 theta equal to 2ixy over iy minus ix. We can rearrange it to become minus 2ixy, and we will let ix minus iy on the denominator. And this is the theta. As we remember, this theta was the angle enclosed between x dash and x. Since we have obtained this condition, the tan 2 theta expression, we have 4 cases. First case, ix is bigger than iy, and ixy is positive. Second case, ix bigger than iy, but ixy is negative. Third case, that ix is less than iy and ixy is positive, and ixy less than iy and ixy is negative. And since this is expression for tan 2 theta, and we remember that for the tan 2 theta we have in the first quarter is positive, and second quarter is negative, third quarter is positive, and last quarter is negative. We are going to have a look next time for the cases, the 4 cases, and how can we draw by using Mohr circle. Thanks a lot and see you. Goodbye.